Okay, so um, let's continue our topic regarding the horizontal curves, particularly on the topic of reverse curvature. Okay, pag reverse curvature, iti-treat lang natin siya again as simple curves. Okay, it is considered as two or more simple curvature. And para ang treatment lang ng computation nito is para lang din siyang compound curve. Okay? So, kung si compound curve, okay, kung si compound curve, meron tayong radius, okay? Then, meron tayo sa pang radius, tapos may curve tayo dito, and may curve ulit tayo papunta dito. Pagdating naman kay reverse curvature is, meron tayo ulit radius, at meron silang common point kung saan magkakaroon ng transition in between the first curvature and the second curvature. Okay? So, ito yung common radius nila. Later on, i-discuss natin kung ano ba yung mga definitions or ano yung mga elements considering the reverse curvature. Okay? Then, ito naman yung next radius. So, almost ganyan din ang itsura ng ating compound curve. Okay? Wherein, si compound curve, nasa isang direction lang siya. So, kung concave siya, kung concave silang dalawa parehas, ito, pagdating kay reverse curve, from the name itself na reverse, i-reverse natin yung concave into a convex. Okay? So, magkakaroon ka ng transition from one direction to another direction. Okay? So, we'll proceed in the discussion of reverse curvature. Okay? First, let's define what is reverse curvature. So, a reverse curve is composed of two or more simple curves turning in opposite direction, just what I said a while ago. Their points of intersection lie on opposite ends of a common tangent and the PT of the first curvature, in which it is coincident with the PC of the second curvature. And that point is what we call the point of reverse curvature or the PRC. So a reverse curve is composed of two arcs of equal or different radii, bending or curving in opposite directions with a common tangent at their junction, their centers being on opposite sides of the curve. Okay? So one good example of this one is etong highway road natin na to. So this is one good example of reverse curvature. So nakikita natin, ito yung curve, ito yung first curve, considering this road, ito yung first curve, ito yung second curvature. Yung radius niya, so meron siya transition dito sa point na to, ito yung radius, okay, at meron din siya radius papunta dito. See, for example, ito yung end niya. Yan, may radius din siya. So, iyan po yung kino-consider natin or kino-compute natin when it comes to reverse curvature. Okay? So, on this part, on this portion, ito yung mga dinidiscuss natin when it comes to horizontal curvature. So, we have here the okay? We have here the simple curve. We have also the reverse curve and we have also here the compound curve. Okay? Pagdating kay simple curve, makikita natin na it's just one plane curve. Okay? Isang curve lang siya. Okay? Pagdating naman kay compound curve, kung makikita nyo, itong portion na to, ang tawag po natin dyan is the clover leaf. Ito, yung portion na yan. That is the clover leaf. Okay, familiar na familiar tayo dyan, no? Kung dumadaan kayo sa Mindanao Avenue, kung dumadaan kayo sa Balintawak Cloverleaf, okay, ito yung portion na yan. Okay, so bakit siya compound curve? Pabilog lang naman siya, sir. So this is one curve, and this is another curve. Okay, same goes with here, no? Isang curve ito, then isang curve ulit ito. Okay, kaya siya nakapag-form ng parang circle or parang close circular formation And this is an example of a reverse curvature. Kung makikita nyo yung mga dinadaanan natin sa NLEX like the Balintawak exit, the Marilao exit, the Bukawi exit, yung may toll gate dito, then bababa ka ng toll gate para makapunta ka sa main highway, sa main expressway, para makapunta ka dyan. So that's an example of the reverse curvature. Okay? So I hope naiintindihan nyo, no? Next, we have 4 types of reverse curvature. So essential ito because kailangan natin ma-identify muna kung ano-ano ba yung mga types of reverse curvature. So this will also ease the computation process natin. First, we have the equal radii and parallel tangents. Okay, we have equal radii and parallel tangents. Next, we have an unequal radii and parallel tangents. Okay, we have also equal radii and converging tangents. Okay, we have also the unequal radii and converging tangents. Okay, si type 1 and type 2, okay, kung makikita nyo, parallel tangent siya. So therefore, the back tangent and the forward tangent are parallel. Pagdating naman po kay type 3 and type 4, si back tangent ay mag-form ng intersection or magko-converge kay forward tangent. Okay? So magtatama yung back tangent and the forward tangent. Whereas sa type 1 and 2, parallel sila. So hindi sila mag-meet. Okay? So those are the 4 types of reverse curvature. Okay? So first type. So we have here the reverse curve with equal radii and parallel tangent. So how do we draw the this reverse curve, the equal radii and parallel tangents? So first, we draw the parallel tangent. Okay? So this will be your back tangent and this will be your forward tangent. And always, si back tangent at si forward tangent is connected by a common tangent. Ang tawag po natin sa line na to na nagko-connect sa back and the forward tangent is the common tangent or the common tangent. Okay? Later on, i-discuss natin how do we compute the common tangents. Okay? The intersection between the common tangent and the back tangent is what we call the point of intersection of the first curvature or the V sub 1 or the vertex sub 1. And the intersection between the common tangent and the forward tangent is what we call the point of intersection of the second curvature or V sub 2 or vertex sub 2. Okay? So, ang sabi sa type 1, dapat daw yung radiuses natin or the radii is equal or are equal. So, we need to position the PRC or the point of reverse curvature at the midpoint of V1 and V2. Okay? Para ma-assure natin ngayon na equal ang radii nila nung dalawang curve, i-position natin si PRC sa midpoint or in between V sub 1 and V sub 2. Okay? Once na-position nyo na si PRC, okay, we draw what we call the common radius. And this common radius is perpendicular line, perpendicular to the common tangent. Again, so the common radius is perpendicular or is drawn or is plotted perpendicular to the common tangent. Okay? So dapat perpendicular or 90 degree ang magiging angle nila. Okay? And then to get the point of curvature or the station of PC, get the distance or the measurement from V sub 1 papunta sa PRC. From V sub 1 to PRC, and then transfer that length or that distance from the V1 to PRC to the back tangent. Okay? And that point is what we call the point of curvature, or the PC, or the station PC. As well as, we get the distance from PRC to V sub 2. Okay? And then we transfer that distance to the forward tangent. And that point is what we call the PT, or the station PT, or the station wherein we get the point of tangency. Okay? Same goes to simple curve. Let's draw a perpendicular line perpendicular to the back tangent to denote the radius of the first curvature. As well as, we get the perpendicular line perpendicular to the point of PT to the forward tangent to get the radius of the second curvature. Once we get all the elements, we now draw the curve, okay, or the reverse curvature. So yan po yung magiging itsura ng ating kalsada or ating reverse curvature. And take note that R sub 1 is equal to R sub 2. Sabi nga natin sa type 1, equal ang kanilang radii. Okay? And also, I sub 1 is equal to I sub 2, or all the central angles are all equal. Okay? So, bakit ganon? So, take note na ang reverse curve at type 1 is parallel tangents. Okay? Pag parallel po ang tangents, ang kanilang mga central angles ay laging equal. Okay? So, we can now assume, or we can now conclude that parallel tangents makes the central angles of the two reverse curvature equal. Okay? So that is for the type 1, equal radii and parallel tangents. Okay? I hope nasusundan ako dito sa portion na to. We now go to type 2. Okay? Sa type 2, ito naman yung portion natin na unequal ang radii, but the tangents are parallel. Okay? Same goes with type 1. We now draw the first two tangents, or the back tangent and the forward tangent, parallel. Okay? And we connect them with a common tangent. At yung common tangent at yung back tangent ay meron pong intersection. They have an intersection, what we call the V sub 1. The common tangent and the forward tangent has also an intersection, and that intersection is what we call V sub 2. Okay? Ang kahibahan ngayon kay type 2 from type 1, ang kino-consider ngayon natin dito ay unequal dapat yung kanilang radii. Kay type 1, para maging equal ang kanilang radii, ang PRC o ang point of reverse curvature must be located at the midpoint or at the middle of V1 and V2. Exactly at the midpoint. Okay? Kay type 2, para makuha naman natin ang equal radii, let's position PRC at either near V1 or near V2. Okay? But in this example, nilapit ko siya kay V sub 1. And that will be our PRC, or the location of our point of reverse curvature. And then, we draw a perpendicular line perpendicular to the common tangent. Okay? So, this common radius must lie at the point of reverse curvature. Now, we get the distance from V sub 1 papunta sa PRC, and we transfer it sa ating back tangent, okay, to get the point of curvature or PC. As well as, we get the distance from PRC papunta sa V sub 2. Transfer natin ngayon siya dito sa forward tangent to get PT. Okay? I hope nasusundan ako sa portion na to. And then, we draw the missing radius. So, draw tayo na perpendicular line, perpendicular to the back tangent, to get R sub 1. And also, let's draw a vertical line or perpendicular line, perpendicular to the forward tangent from PT. And that will be our R sub 2. And then, once all elements are completed na sa reverse curvature, we draw now the curve. Okay? So, this will be the curve. As you can see, mas maliit ngayon si V1 compared kay, mas maliit si first curvature compared kay second curvature. And, pagdating natin sa transition point natin, take note yung term ko, transition point. Okay? Transition point. So, yung transition point is also the PRC. Okay? Pag nag-transition siya dito from the first curvature to the reverse curvature, yung first curvature, kapag malapit si PRC kay V sub 1, mas maliit ngayon yung length of curvature niya compared kay second curvature. Okay? And then, we can now denote that R sub 1 is not equal to R sub 2. But since this is an example of parallel tangents, definitely I sub 1 is equal to I sub 2. Okay? So, questions, clarifications, paki-comment na lang sa ating Google Classroom. Okay? Let's proceed. Type 3. So, type 3, so this is a reverse curve with equal radii and converging tangents. So, ngayon, equal ang radii nila, pero yung tangents ay magko-converge or magtatama sila. Okay? So, let's draw the back tangent and the forward tangents. So, this will be your back tangent. Ito yung back tangent mo. Ito ngayon yung magiging forward tangent. Okay? As you can see, if we extend the back tangent hanggang makarating tayo o mag-coincide siya sa forward tangent, magkakaroon tayo dito ng point of intersection. Okay? Or the converging points of the tangents. Okay? So, tulad ng nakaraan, tulad ng kaninang types natin, let's connect the back tangent and the forward tangent with a common tangent. Okay? May intersection ulit si common tangent at si back tangent. Okay? And that intersection is what we call the V sub 1. Intersection ulit the common tangent at the forward tangent, what we call the V sub 2. Okay? So, pagdating po natin kay equal radii sa converging tangents, compared kay parallel tangents, we position PRC near either sa V sub 1 or sa V sub 2. Again, we position PRC either near sa V sub 1 or sa V sub 2 to get equal radii. Okay? So, I'll position it near V sub 1. Okay, hindi naman sobrang lapit, pero sabihin natin mga 1/3 lang siya. Okay, that will be our PRC. So, we draw a perpendicular line perpendicular to the common tangent to denote the common radius. So, let's get the distance from V1 to PRC and transfer it to the common, to the back tangent. Okay, let's call it as PC. And we also get the distance from PRC to V2, transfer it to the back tangent. Let's call that point as point PT. And then we draw the radius and draw also the second radius. Once all elements are completed, let's draw now the reverse curvature. Okay? And to denote and take note that in type 3, R sub 1 is equal to R sub 2, but since this is converging tangents, I sub 1 is not equal to I sub 2. The converging tangents has unequal central angles. Okay, sana malinaw yan ha. So in type 4, unequal radii and converging tangents. Okay? So, draw ulit natin yung converging tangents. Connecting it with the common tangent. We have an intersection from the common tangent and the back tangent. Let's call it as V sub 1. And we have also the intersection between the common tangent and the forward tangent. Let's call it as V sub 2. To capture the unequal radii, let's position the PRC at the midpoint of V sub 1 and V sub 2. And then we draw the common radius perpendicular to the common tangent, and this must lie also at the PRC. And then we get the distance between V sub 1 and PRC and transfer it to the back tangent. And that point is what we call the PC. Same goes kapag tinransfer natin distance from PRC to V2 papunta sa forward tangent. That point is what we call PT. Let's draw the radius of the first curvature and the radius of the second curvature. Okay? So once all elements are completed, we can now draw the reverse curve. Okay? And take note that in type 4, R sub 1 is not equal to R sub 2, and I sub 1 is not equal to I sub 2. Okay? Questions, clarifications? Kung may questions, paki-indicate na lang sa ating Google Class. Okay? Or you can message me personally para ma-address natin yung questions natin. Okay? Okay, so let's proceed naman sa elements of the reverse curvature. So, meron tayo dito mga elements na siguro babalikan na natin or i-refresh lang natin. Okay? So, we have here the PC or the point of curvature. So, based on our definition of PC, so this is where the curve begins. O, dyan magsisimula daw po yung curvature natin. Okay? Next, we have the point of tangency or PT. So dito naman po nag-e-end yung ating curvature. Okay? So we have here the PRC. Ito yung portion na to, yung PRC. Okay? And that PRC is also called the transition point. So this is where the transition of the first curvature and the second curvature happens. Okay? So dito magta-transition yung curves natin. Okay? Next, we have T sub 1. Okay, so familiar na tayo dito sa T sub 1, no? So this is the length of the first tangent distance. So this T sub 1 lies from PC papunta dito sa point of intersection of first curvature, and from the point of intersection to the first curvature papunta naman siya sa PRC. Okay? Yan po yung T sub 1. And also, we have also the T sub 2 or the tangent distance of the second curvature, which lies from the PRC papunta naman sa point of intersection of the second curvature, and from PI of the second curvature papunta naman siya sa point of tangency. Okay? Next, we have V sub 1. Okay, so nakita natin V sub 1. So that is the vertex of the first curve. We have also V sub 2. That is the vertex of the second curvature. Next, We have I sub 1. I sub 1 is the central angle of the first curve. Okay? So that is located from PRC, from PC to PRC. Itong angle po na ito. Okay? Itong angle na to. Okay? That is I sub 1. And also, we have I sub 2. Okay? Ito naman po yung I sub 2. Okay? Kung ito ay I sub 1, based on our definition sa simple curvature, itong portion na to is also correct, I sub 1. Okay? And this portion, kung ito ay I sub 2, itong portion na to ay I sub 2 din. Okay? We have also here the LCU1 or the length of curvature of the first curve. Okay? So that lies from PC papunta sa PRC. And then we have also LCU2. That is the length of the second curve from PRC papunta naman sa PT. Okay? Next, R sub 1 and R sub 2 are the radii of the reverse curvature. T, okay, is the length of the common tangent. And that T lies from the V sub 1 papunta sa V sub 2. Okay? And it is where the PRC is located. Okay? Diyan nyo po ipapatong ang PRC. Okay? So that is the length from V sub 1 papunta sa V sub 2. And technically, nandyan din po yung T sub 1 and T sub 2. So therefore, we can have the formula of the common tangent as T sub 1 plus T sub 2. Okay, parang compound curve lang. Sabi ko nga, di ba? Parang compound curve lang. Next, we have L sub 1. So that is the length of the first chord. So that lies from PC to PRC. Okay? Next, we have L sub 2. That is the length of the second chord. And that lies from PRC to PT, L sub 2. Okay? So, makikita natin, no? We have here the back tangent and the chord. Okay? This angle, ito, yung angle na yan, from the back tangent papunta sa chord ay ang tinatawag po natin na alpha. Okay? And that alpha, balikan natin, is what we call the deflection angle. Okay? Ang formula nito is I over, okay, that is I over 2. Okay? Kung ang kino-compute nyo na deflection angle is the deflection of the first curvature, definitely this equation must be I sub 1 over 2. Vice versa sa second curvature. Okay? Next, we have here P distance. Okay? So that is the distance between the parallel tangents. Ito yung distance na yan. Okay? So that is the P distance. And this only applies in type 1 and type 2 problems. Okay? Having a parallel tangents. Okay? So kung may question dito sa elements of the reverse curve, please again, indicate it sa ating Google Classroom. Next, additionally, para naman po ito sa converging tangents. Okay? So we have here what we call the theta. Theta is the angle between the converging tangents. Okay? And that theta is computed as I sub 2 minus the I sub 1. Okay? I sub 2 minus I sub 1. So let's derive that formula or that that equation, no? So theta is equal to I sub 2 minus I sub 1. So we know that the central angle of the first curvature is what we call the I sub 1. Ito yung portion na yan. Okay? Ngayon, kunin naman natin yung I sub 2 or the central angle of the second curvature. Ito yun. And then, pag nakuha natin siya, i-transfer naman natin siya dito sa ating first curvature. And then, we draw a vertical line, okay, from the origin of the first curvature, papunta naman sa back tangent. And definitely, meron po yung angle. And that angle is I sub 2 minus I sub 1. Okay? Or what we call the angle between converging tangents. Okay? At yung theta po na ito, okay, ay magagamit din po natin to get the angle of these converging tangents. Okay? And that angle is also theta. Okay? So, kung hindi given si theta, you can compute theta by getting I sub 2 and I sub 1. Okay? And this is also crucial sa mga problems na makakabuo ka ng right triangle. Okay? So, this is only applicable sa converging tangents. Okay. Kay theta din, malalaman nyo kung ang problem ba natin, say for example, ang problem ay hindi sinabi na parallel tangent siya or converging tangent siya. Okay? Kay theta nyo malalaman kung ang problem ay parallel or converging. How? If theta is equal to 0, okay? If theta is equal to 0, therefore, the problem is parallel. Okay? If theta is not equal to 0, therefore, the problem is converging. Okay? Again, if theta is equal to 0, therefore, the problem is parallel tangents. If theta is not equal to 0, therefore, the problem is converging tangents. Okay? Kasi, kung si I sub 1 ay, say for example, is equal to 20, si I sub 2 ay equal sa 20, so I sub 1 is equal to I sub 2. Diba? Type 1 yun. Type 1 and type 2 yun, which is parallel tangents. So, 20 minus 20 is 0. Therefore, theta is equal to 0. Therefore, it is parallel tangents. Okay. Pag yun ay hindi sinabi sa problem. Pag sinabi, goods. Pag hindi sinabi, you can get the characteristic of the problem based on the angle between converging tangents formula. Okay? Okay. Okay, so we'll now proceed sa ating sample problems. Okay. Okay. Problem number 1. So two parallel tangents 10 meters apart are connected by a reverse curve and the chord length from the PC to the PT is equal to 120 meters. Compute the length of the tangent with common direction. Determine the equal radius of the reverse curve and compute the stationing of the PRC if the stationing of A at the beginning of the tangent with common direction is 3 plus 420. Okay? So, let's proceed in plotting problem number 1. Okay? So, let's first draw the two parallel tangents. Okay? Ang sabi dito sa problem, these two parallel tangents are 10 meters apart. So, our P distance is equal to 10 meters. Okay? Let's connect these two parallel tangents with the common tangent. Pakita lang natin yung vertices niya. And the position of the PRC. So, saan located si PRC? So, let's check the problem. Okay? May sinabi ba yung problem? Definitely, sa problem 1, may sinabi. Check natin si problem letter B. Okay? Determine the equal radius of the reverse curve. O, sinabi na dito na equal daw po ang kanilang radii. So definitely, PRC is located at the midpoint of V sub 1 and V sub 2. Okay? So, let's draw the common radius perpendicular to the common tangent. Let's get the position of station PC and the position of station PT. Okay? Sabi din sa problem na yung chord length daw po natin from PC to the PT is equal to 120 meters. So therefore, PC to PT is equal to 120 meters. Okay? Let's complete the elements of the reverse curve. Lagay natin yung radius. Lagay din natin yung radius. Okay? Center, center. And let's draw the reverse curvature. Okay? I hope nasundan yung pagpa-plot, no? Or kung paano natin i-dissect yung mismong problems natin. Okay? Letter A. Let's compute now the length of the tangent with common direction. Ang hinahanap lang po dito ay common tangent. Okay? So, we have the formula of the common tangent as T sub 1 plus T sub 2. So, ito yung T sub 1s. Ito naman is T sub 2s. Okay? So, itong angle na to ay tawagin na lang natin siya as I. Okay? So, this is because equal naman kanina central angle. So, I just named it as I. Okay? Hindi na I sub 1, I sub 2. I na lang. So, let's consider PC, Q, PT. So, we have 3 points. So, therefore, we have a triangle. We have PC, PT, and nasaan yung Q? Yung Q ay located sa intersection ng back tangent at ng R sub 2. Okay? May Q dyan. So, this is your triangle having a leg of 10 meters and a hypotenuse of 120 meters. Okay, hypotenuse natin dyan, din po yung magsisilbing long chord. Okay? Now, what is this angle? We know on the definition of this angle that the angle between the back tangent and the chord is what we call the deflection angle. And that deflection angle has a formula of alpha is equal to I over 2. Okay? So now, almost complete na yung triangle natin, but we can now get I sub 2 or the value of the central angle by the sine function. Okay? So katawa ulit tayo. Sine I over 2 is equal to the opposite, which is 10 meters all over the hypotenuse of 120 meters. Calculating and getting the value of the central angle, we have I is equal to 9.5604 degrees. Okay? Yung I na to ay same lang din sa I na nandito. Okay? Now, meron ulit tayo dito mapo-form na right triangle. So, we have the right triangle considering points V1, V2, and an imaginary line perpendicular to the to the forward tangent. Okay, line na to. Okay? Ay. Okay? So, this line. Yan, yan line na yan. Okay? So, same goes now, sine function ulit kasi meron kang I, meron kang length of the leg, pero ang hinahanap natin is the hypotenuse. Okay? Okay? Or the distance or the measurement of the common tangent. So we have sine I, or which is sine 9.5604 is equal to 10 over the common tangent. Okay? So by cross multiplication, we have 10 divided by sine 9.5604. We can now compute for the value of the common tangent as 60.2093 meters. Okay? So that is the answer for problem 1A. Problem 1B, we need to determine the equal radius of the reverse curvature. Okay? We know that R sub 1 is equal to R sub 2. Okay? Now, let's call it as just simply R, or the common radius. Okay? So we have now we have computed the value of the common tangent as t is equal to 60.2093 meters. Substituting the value of the common tangent to the equation of the common tangent, which is t sub 1 plus t sub 2, we have 60.2093 is equal to t sub 1 plus t sub 2. Since yung problem na to is an equal radii and a parallel tangent, therefore, we have an equal radii of r sub 1 is equal to r sub 2. We have an equal central angle, which is I sub 1 is equal to I sub 2. Therefore, t sub 1 is also equal to t sub 2. So, bakit po equal ang kanilang tangent distances? Okay? Bakit equal ang kanilang tangent distances? As you can see, the position of PRC is located at the midpoint of V sub 1 and V sub 2. Say for example, ang common tangent natin has a length of 120. PRC is located at the midpoint. So it will divide the common tangent into two segments, having a measurement of, or having an equal measurement of 60 meters. Okay? So yun po yung dahilan kung bakit T sub 1 is equal to T sub 2. Okay? So since we know that one, we can substitute the variable T sub 1 sa ating T sub 2. Okay, dito sa T sub 2 natin. So we have 60.2093 is equal to T sub 1. Okay? Cross multiplication, we can have the tangent of the first curvature as 30.1047 meters. Okay? So T sub 1 is equal to R tangent I over 2. So familiar na tayo dito sa formula na ito, no? So palasak na to, no? From simple curve to compound curve hanggang sa reverse curvature. Okay? So we have now T sub 1 and the central angle. So we need to compute the common radius or the radius. Okay? Substituting the value of T sub 1 and the central angle, we have 30.1047 is equal to R times the tangent of 9.5604 all over 2. We can compute the value of the common radius as 359.9992 meters. And that will be your answer for sample problem 1B. Okay? So last problem, problem C, problem 1C. So we need to compute the stationing of the PRC if the stationing of V sub 1 at the beginning of the tangent with common direction is 3 plus 420. Okay? So based on our figure, we can derive a formula for station PRC. So, ito yung kailangan natin makuha na stationing. So we need to go from station PC forward, dadaan tayo sa length of the curvature of the first curve papunta sa PRC. So we have a formula for station PRC as station PC plus LCU sub 1. Okay? So I'll be using chord basis, which is 20I over D, to get the length of the curvature. Nakuha na natin yung central angle. Okay, meron tayo dyan. Pero itong DI, hindi pa. But we can compute for the degree of the curvature of the first curve. By how? By having the formula D is equal to 1145.9156 all over R. Substituting the values of I and R, we have LCU1 as 20 multiplied by 9.5604 all over 1145.9156 all over 359.9992. LCU1 is computed as 60.0696 meters. Okay? So, kulang pa. Wala pa tayong station PC. But we can get station PC by subtracting the stationing of station V sub 1 to the tangent distance. So, babalik tayo from station V1 papunta sa station PC through tangent distance 1. Okay? Substituting the value of station V1 and tangent distance 1, station PC is equal to 3 plus 420 minus 30.1047. Calculating station PC, we have 3 plus 389.8953. Now, may station PC tayo, may LCU1 na, we can now compute for station PRC. So, substituting, we have 3 plus 389.8953 plus 60.0696. Calculating, we have station PRC as 3 plus 449.9649. Okay, so that will be your answer for problem 1C. Any questions? Okay. So, sample problem number 2. So, in a railroad layout, the center line of two parallel tracks are connected with a reverse curve of an equal radii. The central angle of the first curve is 16 degrees and the distance between parallel tracks is 27.6 meters. Stationing of the PC is 15 plus 420 and the radius of the second curve is 290 meters. Compute the length of the long chord from the PC to PT. Compute the radius of the first curve and compute the stationing of the PT. So this is a good example of an equal radii with parallel tangents. Okay? So how do we draw this one? Drawing natin, yan lang din yan, no? So, pag nag-drawing naman kayo, if you're plotting the problem, so it doesn't matter kung mas malaki is radius sub 1 compared kay radius sub 2, or mas malaki ba si first curvature compared kay second curvature. That's fine, no? So, let's complete the elements based on the problem. So, sabi dito, the central angle of the first curve is 16 degrees. So, 16 degrees daw to. And the distance between parallel tracks is 27.6 meters. Yung P distance daw natin is 27.6 meters. And the stationing of PC is at 15 plus 420. And the radius of the second curve is 290 meters. Okay? So first, let's compute the length of the long chord from the PC to PT. So ano hinahanap nating chord? This chord. Okay, itong chord na to. PC to PT. Now, we can consider the points PC, PT, and Q. Katulad ng kanina, no? So we'll be having here a right triangle. Okay? So this angle, okay, natutunan natin kanina, this angle is what we call the deflection angle. So with the formula of I over 2, wherein I here is equal to 16 degrees. And 16 degrees divided by 2 is equal to 8 degrees. From PC to PT, that is the long chord, let's denote it as L. From Q to PT, that is the parallel distance P, which is 27.6 meters. Using sine function, we have sine 8 degrees is equal to the opposite, 27.6 all over the hypotenuse L. We can now compute for the long chord as 198.3142 meters. Letter B. So compute the radius of the first curve. Ang hinahanap daw po natin is this radius. Okay, yan yung radius na yan. Okay? So, kung nagbabasa kayo ng mga libro like libro ni Pesabilia, Gilesania, and so on and so forth, no? You can see this technique, no? Yung dinidivide nila yung upper and bottom portion ng ating parallel tangents. Okay, so parang ganito, no? So from PRC, magdo-drawing ako ng parallel tangent parallel to the back tangent. Okay? And this distance papunta sa back tangent ay tawagin nating A. Okay? So from point of origin papunta sa PC, yan ang hinahanap natin na R sub. So let's compute for the value of A. Okay, what is A? A is equal to R sub 1 minus etong distance na to. Okay? So, ano itong distance na to? Okay? What is this distance? This distance is this portion. Okay? Yan. Yang triangle po na yan. Okay? Having an angle of 16 degrees and a right triangle. So, ito ay R sub 1. Itong portion na to. Itong portion na to ay R sub 1 from PRC to the center of the first curvature. R sub 1 yan. Okay? So, R sub 1, itong portion na to, so cosine 16 degrees. Ang hinahanap natin ay itong leg na to. Okay, itong leg na to. So, that is cosine 16 is equal to this leg all over R1. Cross multiplication, we can have R sub 1 cosine of 16. Okay? Factoring out R sub 1, we have A is equal to R sub 1 multiplied by 1 minus cosine 16 degrees. Okay? I-leave muna natin itong variable A natin and let's proceed to this another technique. Magdodrawing naman ako ng parallel line parallel to the forward tangent, and we have the distance from this forward tangent to this parallel line as distance B. Okay, so we can compute now for B as R sub 2 minus R sub 2 cosine of 16 degrees. Okay? Since I sub 1 is equal to I sub 2, itong portion na to ay, itong angle na to is also 16 degrees. Kaya, ang kinonsider po natin ang kinonsider natin dito ay etong triangle. Yan, itong triangle na to with an angle of 16 degrees. Okay, pareha siya ng I sub 1. Okay, factoring out R sub 2, we have R sub 2 multiplied by 1 minus cosine of 16 degrees. And we know that A plus B is equal to 27.6 meters. So, chinunk lang natin yung 27.6 meters into two distances or two measurements, which is A and B. So, A plus B is equal to 27.6, 16. Okay? Substituting A and B, itong nakuha na natin, na-derive natin na to, sa ating bagong equation na A plus B is equal to 27.6, we have this equation. Factoring out 1 minus cosine 16 degrees, we have the equation R sub 1 plus R sub 2 all multiplied by 1 minus cosine 16 is equal to 27.6. Cross multiplication, we have 27.6 divided by 1 minus cosine 16 degrees. We have R sub 1 plus R sub 2 is equal to 712.4731. And we know, based on the given, R sub 2 is equal to 290 meters. Substituting, we have R sub 1 plus 290 is equal to 712.4731. Okay? Simplifying this equation, we can get the value of R sub 1 as 422.4731 meters. Okay, last problem, problem 2C. So, we need to compute the stationing of the PT. Okay, station PT is equal to station PC. Ito yung PC natin, dadaan tayo sa LCU1, dadaan din tayo sa LCU2. So, I'll be getting LCU1 and LCU2 using the arc basis or Ri multiplied by pi over 180. So, we have LCU1 is equal to 422.4731 multiplied by 16 multiplied by 1 pi over 180 degrees. Calculating LCU1, we have 117.9767 meters. And also, LCU2 is equal to 290 multiplied by 16 multiplied by pi over 180. Calculating LCU2, we have 80.9833 meters. Okay? Given naman si station PC, na-compute na natin si LCU1, na-compute na rin natin si LCU2. We have station PT is equal to 15 plus 420 plus 117.9767 plus 80.9833. And station PT, calculating it, we have 15 plus 618.9600. Any questions? Okay? So those are the problems and those are the principles when it comes to reverse curvature. Okay? So I hope na naintindihan niyo to, no? So problem 1 and problem 2. Okay, I'll be posting the this PowerPoint presentation, ipPDF ko lang for you to have a copy of this one, no? Again, reverse curvature is just compound curvature, no? Ni-reverse lang natin yung direction ng isang curve. Okay? So, I'll be adding another sample problems, another 2 more, no? Para magkaroon kayo ng idea how we can compute or solve the problem when it comes to parallel tangents and also converging tangents. Okay? For questions, just leave it on the Google Classroom or you can email me. Okay? So I'll be posting also the problem sets para masimulan nyo na, no? Problem sets ay problem set of reverse curve and also the spiral curve. So isasama ko, ipag-iisay ko na yung problem set. Okay, so that will be due on for 1 week. Okay, 1 week ang due date niya. So that will be Friday next. That is Friday. Wait, let me check na. Yeah, Friday next week na. So not April 12 muna, no? Since yung week ng April 8 to 12, I'll be posting also the recording. Magre-record ako for the spiral curvature naman. Spiral curve naman tayo. Okay, so that's it, and thank you. And I hope na naintindihan niyo yung reverse curvature. And see you soon. Stay safe, stay hydrated, and God bless us all.